Okay, we're looking at a mini test from week 30, and we're looking at question 1. So I've got a particle projected with an initial horizontal velocity of u meters per second, and it's projected from a point which is 20 meters above a horizontal plane, and it hits the plane a horizontal distance of 35 meters. So let's get that sketched out. So it's being projected perfectly horizontally, so it's just going straight across to the right, but of course gravity is going to make it come down, and I'm told that it started 20 meters above the horizontal plane, and it hit the horizontal plane a total of a distance of 35 meters horizontally. So I'm going to use SUVAT, and I'm going to have to look at the vertical and the horizontal motion. So we're trying to find the initial velocity, and what's going to connect the point where it hits the ground is time. So if I start looking vertically, so vertically the initial velocity was 0 because this was projected perfectly horizontally, so it wasn't moving down at all. Acceleration, so I'm taking down as positive, so acceleration will just be g. You could take up as positive, and in which case acceleration would be minus g. Okay, as long as you're aware of which you're taking as the positive direction, it work out. The displacement, it goes vertically as 20 meters. And again, if I'm taking down as positive, that's 20 meters down. And I'm going to figure out how long it took to do that. Because if I can figure out how long it took to fall, or to drop 20 meters vertically, I can then figure out what speed would it have to be going at so that it traveled 35 meters horizontally in that same time. So I'm going to use S is ut plus a half at squared. So 20 is 0t plus a half gt squared. So if I times up by 2 and divide by g, that will give me t squared. So g is 9.8, so if I do 40 divided by 9.8, I get 4.08, and if I square root that, I get plus or minus 2.02, and because it's time, the negative one doesn't make any sense in this context, so it hits the ground after 2.02 seconds. Right, so now I know that, I can start thinking about its horizontal motion, because horizontally, its initial velocity was u, yeah, and that's what we're trying to find. It travels 35 meters, and acceleration is 0. So because we ignore air resistance. So basically, I could use SUVAT, and I know that took 2.02 seconds. So I could use SUVAT, or I could just use that velocity is distance over time. So velocity is distance over time. So 35, still got that previous answer saved. So its initial horizontal velocity was 17.3 meters per second. Okay, and then, so that's going to be 3 of those 4 marks, and then I've got to say what modelling assumption I use. I've already mentioned it, but basically we assumed there was no air resistance, and it's worth just saying what, where you actually use that. So therefore, the horizontal acceleration, what did it need than that, is 0. Okay, so I use that assumption in this calculation here.